Here we are in our lesson on volume. This is actually volume 1. And what we're going to do is I'm going to give you formulas in order to find volume of different shapes. And you're also going to find like missing sides or missing parts of the shapes. Now, if we were having our regular school session, we would actually be doing a lot of different things from volume. And because of our time constraints and we only have a couple weeks left, we're going to be actually cutting out a lot of stuff. If you were in school, here are some of the things that we are cutting out. Euler's theorem, cross sections, polyhedrons and 3D classifications, and a really big one, especially on the EOC, which you're not taking this spring because of our unfortunate mishap with the COVID, is density. And density is a really big component to volume. But those of you who goes into physics, you'll get a big dose of this. Okay, so what is volume? Well, we all know that we like to have our sodas, water, Jello, no-bake classic cheesecake. All right, so these containers, these things I'm showing, deal with volume. It's basically, how much stuff goes inside of a three-dimensional shape. And so what we're going to do is we're going to focus basically on polyhedrons and some non-polyhedrons shapes where you're going to find out, how much does that container hold. A lot of you have had volume before, especially in middle school. So your teachers should have actually kind of gone over a good bit with volume then. It's just that when you're in geometry high school, we're supposed to take it a step more. And what you're trying to find lots of other missing parts, density, like I said before, and other things. So we're going to break this up into two separate lessons, Volume 1 and Volume 2. Volume 1 is going to be based on the polyhedron, or I should say the prism and cylinder. Now, a prism is a three-dimensional shape in which most of the faces, or if we had that lesson, the sides, are in the shape of rectangles. So if you look at this shape right here, this would be a rectangular prism. I'm sure a lot of y'all remember these shapes right here, a cube. All right, that's where you have all sides as a square. And then you have other shapes such as a triangular prism. Now, what makes these prisms is that most of the sides, notice I said most, majority of the sides are rectangular shaped. In other words, it has to have 4 right angles. So if you look at each one of these shapes, each one of them has a majority shape that has 4 right angles in it. So in this one we have every side has 4 right angles, and every side has 4 right angles this. But in this one we have 4 right angles in 3 of the sides, the bottom, the side, and the side. Now, that's what makes it a prism. Now, to get the first name, prism is kind of like a last name, like your last name. The first name is based on its base. Now, the base is the minority. In other words, it's the shape that you see the least of. So if you look at this shape here, we have 2 triangles and 3 rectangles. Because we have a majority of rectangles, that's what makes it a prism. And then you look at the minority sides, we have two triangles. So we have fewer triangles than we do rectangles. So that would be kind of like its first name. So this would be a triangular prism. And that's what we're going to look at in our first shape. So we're going to look at the prism, and then a little bit later on in the lesson we're going to talk about the cylinder. Now when we hit volume 2, we'll talk about the other shapes. This is the most basic of all shapes, the rectangular prism. Anytime you buy something in the store that's in a box, just like I showed you the Jell-O classic cheesecake box, or basically any box, they need to know the volume of it so they know how much stuff can fit into that, when they are setting the price of it and giving it to the consumer. So this is a really, really important concept, and it's actually used in many, many different applications. Well, this is the most basic. In middle school, this was probably the first shape that they introduced you to in volume. Now, when you have volume, you're saying how much of something can go inside of it. So let's say that we have these 1 inch by 1 inch by 1 inch cubes, and we want to see how many of these cubes can fit inside this container. That would be volume. So this is going to be like number 2 on your assignment, and the formula is volume equals big B times H. That's base times height. When you are introduced to prisms and volume, all you have to do is multiply whatever the area of the base is and multiply it by its height. Now if you look very carefully, we have a rectangular base. This is the base of our picture. Going back to our area lesson, to find the area of a rectangle, you would say base times height or length times width. So I would have 10 times 4. So 10 times 4 is the base. And then here is the height of it, times 6. Now if you want to do a shortcut way, you could just say 10 times 4 times 6. Length times width times height. And that's kind of an old way of doing it, but in our geometry curriculum we use big B, the base. So 10 times 4 is 40. 40 times 6, 240 inches cubed. Alright, so a nice easy problem to start out your assignment. Okay, this is going to be problem number 3. And on problem number 3, what shape do you think it is? Well, let's see what the majority shapes are. We have a rectangle, we have another rectangle, and we have another rectangle. So the majority is a rectangle, so that makes it a prism, and the minority is 2 triangles, so this is a triangular prism. Alright, now the formula for any prism is big B times H. So what is the big B? Now a lot of students will mess up and they'll say, well, the base is 8 and 5 because it's sitting on that rectangle. No, in a prism, whatever the minority shape is, that is the base. So since the triangle is the minority shape, it's the shape that you see least of, that is big B. And the other number that goes 3-dimensionally with it is going to be the H. So you say, well, how can that be the height when it's sitting along the ground or surface? Well, it's kind of like this shape is fallen over or something. So in other words, the height, just imagine if I was to pick this wedge up, the 5 would be up and down then. Alright, but it's been laid over. So here is our base, here is our height. Now, triangle, remember the formula was 1/2 base times height. And you always look at the little square, the little right angle, so that's going to be your B and H. So 1/2 base 8 times height 6. 8 times 6, 48, divided by 2 is 24. That, class, is big B. That's your base, 24. And then I multiply it by its height, which is 5. So I take 24 times 5, and you get 120 units to the third power. Now, I failed to mention that earlier. Remember, volume is cubic, third power. All right, that's where they get cube from, because it's how many cubes can fit inside of these three-dimensional shapes. Okay, this is also a prism. Why is this a prism? Well, because the majority of the shapes are rectangles. So I have a rectangle down here, I have one here, up on top, over here on the side. So I got 4 of those. But look what our minority shape is. The minority shape is a trapezoid. So yes, this would be a trapezoidal prism. And so we use the same formula, V equals to base times height. Big B times H. Now, the minority shape is the trapezoid. So here's our trapezoid. Now let's remember, what was the formula for a trapezoid again? It is 1/2 B1 plus B2 times H. So this is what we're looking for. We're looking for big B, the base. Now I have B1, 15. I have B2, 20. But I don't have a height. I need a height. So how am I going to find it? Well, there it is, the right triangle. I have to use the Pythagorean theorem in order to figure out how tall it is in order to get the height. Alright, so let's come over here. We have a squared plus b squared equals c squared. That would give us 5 squared plus b squared equals 13 squared. 25 plus b squared is 169. B squared is 144 because you have to subtract. So b equals to 12. Alright, so 12 is the height of our trapezoid. So I will place 12 right here. 15 plus 20 is 35. Take half of 35, multiply it by 12, so 35, divided by 2 times 12 should give you 210. Now 210 is big B, so I can put 210 right here. Now, what is our height? Yes, 12. It's that side that makes it three-dimensional. So I'm going to multiply this by 12. So 210 times 12 gives you 2,520 units cubed. Alright, so a few steps in order to get that one. Okay, that last problem was problem number 3, so this would be number 4. No, I'm sorry, 5. This is 5, the last one was 4. So we need to find the volume of a cylinder. Well, the cylinder is in the same formula family as the prism that you will actually still use. Volume equals big B times H. Now where it's going to come different is next week, so our next assignment when we do volume 2. Alright, now what is the shape of our base? Well, you say, well, I thought the minority would be the shape, but this is a cylinder, and so since this is a cylinder, our base is actually going to be the circle itself. So remember, the area of a circle is pi r squared. So this will be pi 10 squared. Now let's put this in our calculators. So pi times 10 squared is equal to 314.2. All right, you get 159, so we're going to round that to 0.2. So this is going to be our base. And then we have our height, 15. So let's take the 314.2, multiply it by 15, and we get 4,713 centimeters cubed. Okay, pretty simple. For the last two problems, we want to find like a missing side. So in this case, I'm giving you the volume and two of the sides of a rectangular prism, and you have to find a third side, or x. Alright, so the best way to do this is just to write out the formula. Volume is equal to big B times H. Well, what do we have? V is 240, so I'm going to put 240 right where V is, and then I have a base of 12 by x. So 12 times x is 12x. And then I have a height of 4. Now you have 2 or 3 ways you can go ahead and solve this problem. If you want to go ahead and multiply 4 times 12, you can. If you do so, you get 48x. Well, that makes it easy. So just take your calculators, take 240 divided by 48, and you get 5. So x equals to 5. Now, if you wanted to, you could have said 240 divided by 12, and then divide that by 4, and you should still get 5 also. So that one was pretty simple. And finally, for our last problem, will be number 7 on your team's assignment. You are going to find the radius of a cylinder with the volume given. So again, let's write down the formula. Volume equals base times height. Our base is a circle, and volume is 1,115.27. That's equal to pi. Well, what's r? We don't know. That's what we're looking for, so we're going to put an x there. That's x squared. And then times the height, which is 14.2. So volume is pi radius squared, that's your big B, and then the height of h. So that's where I got each one of these numbers. Now, when you're working this problem here, this is probably going to be the best way to do it. Take your calculator, put in the volume in first, 1115.27. Then you are going to divide by pi, and you're going to divide by 14.2. So let's divide it by pi. Don't forget to press equals now. Divide by 14.2 equals. So we get 25.00010, so on. Now, once you get to this point right here, 25.0010, so on, you're going to get x squared. Well, we don't want x squared, we want x. So remember, in order to find x, we need to take the square root. So after you put those in your calculator, come over to the left side, find a little 2 with the little square root and x, square root, and that gives you 5. So the radius of our circle, or I'm sorry, our cylinder is 5. Okay, and that's your lesson for this week.